Welcome you all to this Cryo-EM course. Last class we already discussed about the ray diagram. So initially we discussed about the aberrations, then different type of aberration corrections and how it is affecting our images, power spectrum, and then we already discussed about the ray diagram, that okay, C1 lens, C2 lens, how that C1 and C2 lens is controlling the electron dose, and for biological science sample that is very important. And the next we also discussed that parallel electron beam is important, and that time we learned that two important point, that is the back focal plane and the front focal plane. So back focal plane is just the first imaging plane we can consider, it is just after the sample. So electron beam will interact with the sample and then we can get images on the back focal plane. And if we just consider the opposite, if your sample is here and electron beam is merging somewhere here, that is called the front focal plane. So where it is merged, so where we can get the converged electron beam, that will also help us how to make the electron beam parallel. So we discuss all about this. Now what about the specimen holder and the stage? One more thing, it is very important that using this ray diagram, how we can make the converge, how we can get the parallel electron beam, how we can control the electron dose. It is a very complicated system. It is not very straightforward that within a 1 or 2 lecture we can explain all these things. But whatever I showed you, it is a very basic diagram. There is no mathematical calculation is there. So only just I use couple of ray diagrams to explain how that we can control the electron dose and how we are getting the images, because this class is mainly for biology student. So let's that is one of the reason we don't go in depth that okay, what other changes it will be there, if there is a C3 lens, how it is going to control, or how we can make those electron beams in a different diameter. So those you can definitely get it if you just study the manual of any instrument, how to control those things, and those will be much more appropriate when students or researchers are operating the microscope. If you are not operating this microscope, this basic knowledge will be good enough. Now when we are talking about the objective lens, if your sample is there and electron beam is passing through the sample, then first we should know that how we are getting our samples and what do we have there, how we can insert that sample. So let's take a look. There is a two types of sample holder we can discuss about that. Okay, there is a so there is a two types of sample holder we can consider. The traditional sample holder, if we just consider, that is the side entry holder. So if we have the column and you have a goniometer at the side, when I was showing you that electron microscope diagram, and I always showed you at the side there is a goniometer or stage where you can use the traditional side entry holder. And the side entry holder, basically it is a rod, and this rod is almost 1 feet or little bit longer than 1 feet, and it is a motor attached with that holder, which is helping us to tilt, rotate the specimen. So you can use that holder to tilt, rotate the specimen holder, and sometime you can use this holder connect with the liquid nitrogen dewar. If you want to heat that one, that is also is possible, because some sample is heat sensitive and you want to see the morphology change of that sample during the heating the sample. So there are different types of holder it is available. That some holder you can use it at liquid nitrogen temperature, that is liquid nitrogen dewar will be connected with that. There will be some holder where you can have a power supply and control box. So there you can hit the holder and see the morphology change of any material. and also you can change the position of the holder. Now there is a traditional top entry holder. Generally most of the time we are not using this top entry holder very frequently nowadays, but previously we are using a top entry holder where we are using the cartridge. That cartridge we are going to use it when we are when we are prepared the cryo sample. This cartridge term it will come again and again, but we are not using top entry holder for our cryo-EM purposes. And now when I was talking about the grid is a metal something, it is a circular, and I told that diameter of this one will be 3.05 millimeter, and also you can see there is, it is written 3505 millimeter. So I'll show you a diagram where we will discuss about the holder. In that holder you have a, at the top part you have a position where this 3.05 millimeter grid can go and fit there. There are some holder where 2.3 millimeter diameter grid can also fit, but mostly nowadays we are using that this kind of holder and this side entry holder. Now take a look how this holder look like. This is a diagram of this holder where there is a diagram of this holder where you can see that okay, this is a long rod which is connected with a area which you can hold and insert. There is a pin is also there. That pin is going to go inside and attached with that microscope, and there is a O-ring which is controlling any leakage. This O-ring is helping to fix, and here this is the objective lens. You can see this is the objective lens, and this is the holder tip, and holder tip, this is the area where your grid can stay. If we just look at this holder tip, you can see this holder tip, it will be something, it will be motor controlled area. This is the metal area, and your grid can go somewhere here. So this is the empty place where your grid can go, and there will be a slip which will hold this grid here. So here you can see your grid is there, and electron beam can pass through this to give you an image. Now what is the function of different component? So O-ring, which is an mechanical link to the microscope column. So if you just go back here, if you just consider, this is the part which is directly connected with the microscope, and this is the pin that is also connected with that microscope, which is helping to any kind of tilt angle. So there is a two contact point of this holder with the microscope. One is this O-ring and one is this pin. That will show you how this pin is helping when we are inserting the holder. So if you look at this O-ring, which is one mechanical link to the microscope column. Some holder have two O-rings, and the gap between the two O-rings is pumped separately to improve the vacuum. So previously I told that sample holder area, or that stage or goniometer, is the area where we are going to insert the sample holder, and that is the area where we are directly going to insert something inside the microscope. So we are going to break the vacuum near the goniometer area. So that is the reason we have to be very careful about the vacuum. If we are very casually trying to insert the holder, or if we are not well trained, we are going to break the vacuum of the entire microscope, and that is going to affect our lens system as well as our filament, and microscope will be contaminated with moisture and other substance. So it will be always good to, when we insert the holder, we should be very careful during the insertion, and we have to be careful that we should not damage the vacuum. So here when we are talking about the some holder has two O-rings, and there is a gap between these two O-rings, and then we are pumping that to improve the vacuum, because that is the area where we are inserting the holder, and the entire column is under vacuum and we are inserting the holder. That means somehow we have to break the vacuum and then we can insert the holder, otherwise we cannot insert the holder. So that is the reason in this particular stage we have to be very careful. Now we will go to the next step and I will explain you how we can insert that holder. So if you look at that, so this is the grid we are talking about, that these are the metal bar area. So most of the time you can get copper or nickel. So nowadays mostly you can see the copper grids. So here you can see those are the metal bar. So in this is the area is completely empty. And this is the other metal bar where it is coming like that and it is forming this square. And when we want to image something, we have to target those empty area which is coated with amorphous carbon, and this carbon is so thin electron beam can easily pass through this carbon and give us an image. So if we are targeting imaging somewhere here or those metal bar, we cannot see any beam because beam will be completely blocked. If we want to image something, we have to target these individual squares inside of this individual square and we can see. Now if you look at that, there are different sizes squares are there. So in some cases only 75 squares are there or 25 squares are there. Some cases you can get it that okay, there is a 100 squares are there or 200 squares are there or 300 or 400 squares are there. So those squares are, it is telling that mesh, that 100 mesh grid means you have 100 squares or 200 or 300 or 400. Sometime that 200 300 mesh grid you can see individual squares are very small, but if you have 100 mesh or 50 mesh grid, your those squares are comparatively very big. So those cases that on top of this one you need a platform and then you need a amorphous carbon on top of this, and then your electron beam will go through those and you can image, and your carbon layer whatever we are talking here, the individual square or entire grid will be covered with a carbon layer, and that carbon will be really thin. If it is a very thick carbon, electron beam cannot go through that carbon and it will affect our imaging, our contrast will be very poor. Now I will show you one diagram or animation image how we are inserting the holder inside the microscope. Before that you have to understand how that holder is working. So let us take a look how holder is working. So this is a column and inside that column you cannot see that column because it is not transparent. Outside will be a very thick metal, it will cover. So that is the reason you cannot see anything inside there. Inside that column there is a lock and the holder has a pin, that is I told you that holder has a this kind of long rod. And if you look at this thing, so holder will be generally like that, your sample will stay here and holder will go inside the column. If this is the column, it will go inside. So goniometer is something like that where you have to put this holder in first. Whenever you are trying to insert that holder, what is happening, you are going to break the vacuum and lot of air and moisture go inside the column. So if you put a lot of moisture and air inside the column, your column will break the vacuum because it cannot maintain that high vacuum whatever is required for the electron microscope. That is the reason, first if this is your key and I told there is a lock inside the goniometer, if this is your goniometer, there will be a lock here and you cannot see that lock, and that lock there is a pin on the holder, that pin can go and fit into that lock. If it will fit properly, it will trigger the vacuum in the goniometer. So what will happen if this is your goniometer and you just consider this small bump is your pin and it is going and fit here, and here you have a O-ring, that O-ring is giving you that protection, it is touch the microscope and it is airlocked in that position, and entire goniometer there will be a pump, it will start immediately, and try to keep this one under vacuum. So, in this particular stage, whenever you will try to insert the holder, holder will go in, your lock is inside, pin will go and fix here. When that will fix, it will trigger the vacuum, it will switch on that pump and it will start pumping that area, and it will remove most of the air and moisture from that area, and that pump will continue for 90 seconds, sometime 120 seconds. So, you have to give that time. When this will reach a proper vacuum, then you can insert the holder. So, let us take a look how this holder is working. Here this is our column. If you just look at, this is our column. This is our objective lens system that we already discussed, that this is a objective lens system. Objective lens we already discussed couple of times, that it has a upper objective lens, okay. So, it has a lower objective lens. So, this is our lower objective lens. Now, this is our holder we are talking about. Your O-ring is somewhere here, that O-ring is going to connect with the microscope, and this is the pin I am talking about in your holder. So, this is the pin and you have a lock here, you can see inside the goniometer. That is, I was showing that inside the goniometer there is a lock, and this is the key, this pin. So, we will take this holder, we will put the grid here, and then this entire holder it will switch here. Let us take a look how. So, this is the holder, there is no grid at the beginning. Now, we are adding that grid. So, now grid is added here, okay. Now, this entire setup, this entire holder, it will move from here and it will go towards the goniometer. So, now you can see we fit that gradually, it is not very fast, you have to slowly insert and find out this lock. This lock you cannot see it, your pin you have to put it in certain angle, so this lock and key can fit properly. And you can see there is a valve. So, your entire column is under vacuum. So, that is the reason your holder cannot go directly and go inside here. So, that is not allowed at the beginning. So, here what we are trying to do, we inserted the holder, this pin is fixed here and it triggers the pump system, and pump is switched on, and there is a valve, this valve will be closed all the time for now. So, then when this pump started, pump will start working and it will remove all the moisture from this goniometer area. This is the entire goniometer area. This entire goniometer area, all this air and moisture will go away. So, in this particular stage we have to wait almost 60 to 90 seconds, or sometime 120 seconds is also required. Based on the facility we have to follow that protocol. So, here you have to wait because pump is switched on and pump will start vacuum this entire goniometer area. When this goniometer is already clean, there is no moisture, then this entire goniometer will rotate almost 180 degree, it will rotate. So, now you can see there is a rotation of this entire holder. Now, this pin and entire system is moved in opposite direction and then it will go inside. So, here I wrote too many things. So, I will just do one thing, I will just go through this cycle one more time. So, it will be easier for all of you to understand how this is working. So, this is the holder we have. So, this is the holder we have, this is the holder tip. Now, you can see grid is come and fixed here, and this is the pin, this pin will go and lock in this particular position. Then entire goniometer, this is the goniometer, it will be under vacuum for some time, some 60 to 120 seconds. When it will reach in a particular vacuum, then the entire system it will rotate 180 degree. Now, when this 180 degree it will rotate, this is the valve, this valve will open up. When this valve will open up, holder can go inside. Now, you can see that holder is inserted. Now, electron beam can pass through this sample and we can get the image. So, this entire process we have to be very careful and you need lot of practice for this one. Now, when there is a entire system that I told, those are the objective lens, upper objective lens, lower objective lens, holder is inserted. This is the goniometer, the pin and lock is the system. You can see valve is completely open now and holder can stay because this entire system is now under the vacuum. So, this vacuum system definitely we have to discuss in the next class. Also, here one important point is that here there will be a nearby region, there will be a cryo box and the cryo box will be connected with a multiple copper wires like this. So, which will be embedded in a liquid nitrogen diode in somewhere here, which will maintain the temperature of this cryo box. If the cryo box temperature is maintaining minus 180 to minus 190 temperature, so biological sample will stay stable within this cryo box. So, it is not only that upper objective lens, lower objective lens, you need lot of practice when you will insert the holder. Also, it should be connected with the liquid nitrogen to maintain the vacuum and protect the biological sample. So, this is all about sample insertion, and this is specially for if we just consider about normal TEM, whatever we are talking about, that normal transmission electron microscope, and this normal transmission electron microscope we are using negative staining and it is in a room temperature. So, you can see whenever you are looking at those holder, there is a no cryo holder or liquid nitrogen diode is attached. So, the whatever grid we are inserting in the sample, it is in a dry condition. So, this type of sample holder goniometer we can use it for room temperature sample. We can use this sample for negative staining at room temperature, and we use that cryo box to maintain the vacuum, sometime protect the biological science sample. But cryo holder, it will be completely a different setup that we are going to discuss, or when we will give a demo of the microscope and show you the sample preparation thing, that time I will describe that. At the next class we are going to discuss more about the maintaining the vacuum inside the microscope and the sample preparation techniques. So, thank you all for your attention. I will see you next class.